All right, everyone. Here I want to present what's called maybe a surefire way to compute limits at infinity. Oops. And in class, let's do an example. Let's review. In class, we had an example where we had something like the limit as x goes to infinity of 3x to the fourth minus 5 over 4x to the fourth plus x, maybe. And our intuition was when the denominators are the same degree, in this case we have same degree polynomials on top and bottom, then the answer is just going to be the ratio of the leading coefficients. So this is all the work that you'll have to show on the exam. But I want to just show again what we could do is we could, when computing this, if we didn't want to sort of rush to the answer using our intuition, we could multiply by 1 over the degree of the denominator. So in this case, 1 over x to the fourth. And if we do that and we simplify, I'm going to skip some algebra steps here in the middle, but we're going to get 3 minus 5 over x to the fourth, and then we're going to get 1 plus 1 over x cubed. And now when we plug in infinity, well, the point is that if we look at these terms with the x's and the denominators, as x goes to infinity, 1 over a huge number or 5 over a huge number, those are going to be really small. So those basically go to 0. And so when we simplify, we're basically just going to get 3 over 4. And that's what's going on. So let's do another example. So let's do one, say, where we have the limit as x goes to maybe minus infinity of x cubed over 2x plus 1, say. Let's see what's going on here. Well, our intuition, again, says bigger degree on top. So the answer should be either plus infinity or minus infinity. That was one of the things we got in working through the worksheet. And to figure out the sign, well, we should imagine if we plug in negative infinity, well, if we plug a negative big number into the numerator, we'll get a negative number. And if we plug a negative number into the denominator, we will also get a negative number. And so a negative divided by a negative should be a positive. Okay? So that should be our answer. But let's check that another way. So let's do our trick where we divide by the degree of the denominator. So in this case, we divide by x, and we divide top and bottom by the same. So what we're going to do once we simplify is we get the limit as x goes to minus infinity of x squared over 2 plus 1 over x. We can do the same trick before, noticing that this term is going to go to 0. And now when we simplify, well, we're going to get minus infinity squared, and then we're going to divide that by 2. So we're imagining plugging in really large negative numbers, squaring them, and dividing by 2. In the end, we should still get positive infinity. And so this is sort of a surefire way that will work for computing any limit. Just make sure when you're dividing, the factor that you're using is 1 over the degree of the denominator. So I'll just sort of connect those things. But again, I encourage you to just use your intuition with these problems and argue, what's happening based on size and thinking about positive and negative, because I really think that can go a long way. So thanks for watching.